We are going to show you I'm going to show you how we can split the data in training and testing side. So as we know that we have the few libraries which is helpful for the training, splitting the data to the training test and testing sets. So let me show you like how we can do that. So here I just imported my data my complete data frame containing lots of column. You can see here latitude, longitude, house medium and all other column as well. So here if you can see that I need to split the data, because if I like do the shape here, so you can see that I have like 20,640 rows and 11 columns, right? So this is the my complete data set, but to training my model I need to split this data into two steps: training and testing sets. So we will do with the help of the sklearn library. So you can see here my I am just importing the sklearn training test split function. So after that I am just splitting this data into 0.2, means 80 20%. 80% is for the training and 20% is for the testing, and with the random state like 24 or 42, and the we will shuffle is true, means we are getting the shuffle data. So what if I tell you this method is wrong? Because I will explain you like how this method is wrong and how the data is create the problem in future if we do using this method. So here we are successfully split the data right into training and testing. So you can see here my train is like in my training set we have 16,512 rows, and in my test set we have 4,128 rows with the same number of columns. So if I do here like head function, so you can see here I have like all the data, right? And in the test as well we can see here I have all the data. I'm just printing first 5 rows, but you can print as much as you can. So but see how we can let's see like how this method is wrong and which is the best method or the correct method to split the data. So here we can see that I write something, right? So I will explain you step by step. We successfully split the data to the training and testing sets. So but like I just do a spelling mistake. So yeah, so yes, so we did resampling as well, right? So we also like shuffle as well, and resampling is also called as shuffle. So we did that as well, but still test data is not represent the actual population. How we can do that? I will explain you how to find that and how we can do that and how we can predict the actual population. But our test data is biased. For example, let me give you the one example which contain we have like 1000 data points. I have some data set of the male and female which contain 1000 row. After resampling we divided it to the 80-20. 80% is for training and 20% is for testing. So our 1000 data points we have contained 55% in that, means 550 points. So yes, 550 point is the male people point, or the male the 550 data points or 550 rows contains the data of males, and our 450 rows in our data set contain the females data. So here you can see that, and in our test data, means we just rip sample and all the things we do, right? And after that we got that like we have split the data 80-20, and after we observe that in our test data we got like 50% male and 50% female. So actually our population contains 55% male and 45% female, but our test data contain 50% male and 50% female. So our test data is not like the actual population, means test data is not like us like reflecting our actual population. The test data is biased data because of the not actual means test data is biased data and it's not reflecting the actual population. So in that way, means we are doing everything right now, still algorithm will not predict the output which actually we required. That's the happen when we are doing the live production or and live testing. So why this happen? Because of these mistakes, right? So it should be every time we must need to like find our training data and the testing data is the actual representation of the population. If it's 20%, still it's need to be the actual representation of our population. So I hope this point is clear to you. Why I am saying that okay, this is not and this is not like that. So this is the like problem, right? Our testing, if we split in this way, then our training data, our testing data is biased to the specific categories, and in that way our prediction will be wrong because the actual thing is not present and we are predicting something which is not actually there. So that's why this problem is arises. And how we can solve the problem? There is concept called stratification for solving this problem. So I just have here to do some bold activity. You can see there stratification. So what in that stratification, what we are doing, right? We are just like I will explain you like step by step how we can solve this problem and how we can do that. But let me explain you how stratification works. So in stratification, what we need to do is like we need to choose one column which contain or which has the highest correlationship with the output. Means in my data I know that because I find in the mathematical way I found out that okay, my median income column has the highest correlation with my output. But you can find out using the correlation function. I have already explained one video regarding that in my previous videos. You can check that how we can find the correlation and all. So I found out that my median income is the highest correlation with my output. So this is the column which is has like most affect my output. So this is very important column in my data set, right? So what we can do in the stratification, what we can do, we can select the medium column. We can it's a medium column, medium income column contain the data, regression data, the continuous data. But in the stratification we need a characteristic data, or we need the data, it should not be the continuous or discrete data we require. So we need to convert data to categorical data. We can say it's ordinal data, we need to convert that. So what is the ordinal is that the range matters, or the priority matters in the ordinal data. You can search the Google as well. So we can convert data into the categorical data. Once that is done, then we need to divide data, or we need to split data based on that category. Then this is the complete way, this is the complete setup. So in this way we can bypass the problem of the stratification. So we need to find the column which is contain the affecting most of my output. Then we will convert that column to the categorical data, and then split our complete data structure based on that the categories. So we will reduce the risks of stratification. So in sometimes you are saying like okay, we are dividing this data based on the resampling, means randomly picking the values, right? But there is 10% possibility that our data will be biased. So the 10% is lots of possibility, means it's content like 10% means happens once in 100 times, or happens 10 times. If you are resampling the data 100 times, then there is the possibility 10 times that this output will come, or this problem will arise. So for solving this problem, what we need to do is like, for solving that or removing that 10% possibilities, what we need to do, use the method called stratification. So in the medium income, convert data to the categorical data and split data based on that data, so that category. So let me explain you how we can do that programmatically. So here you can see here I'm just printing my DF head first 5 rows. So you can see medium income, right, contains some values 8, 8, 7, 5 and 3, something like that. So what I will do, I will convert that my category from 0 to, if my medium income column contain values 0 to 1.5, then I will be put in category 1. If my medium income column contain 1.5 to 3, then I will put in category 2. If my medium income column contain 3 to 4.5, then I will put category 3. If my medium income column contain 4.5 to 6, I will put in category 4. If 6 to infinity means greater than 6, then I will put in category 5. So why I choose this category? Because I know that most of the data is between 0 to 6. So that's why I created category, and I have data contains some outlier. So for making the outlier or using that outlier or treating that outlier in the good way, so that's why I create the category which is contain 5. So I know that because of the graphs and all, we can draw the graphs. I didn't draw here, but you can draw as well and check that. So that's why I create the category in this way. You can create based on your data. So here you can see here, like I am creating one column which is called income category. So income category, so this is the cut function which is helpful for converting our like regression or the continuous data into the categorical data. So what I am doing, like I am doing that the column name which I want to treat. So medium income column, I will set up the beans. Beans means the category. So 0 to 1.5, 3 to 4.5, 6 to infinity, something like that. So I am creating here 1, 2, 3, 4, 5, 6 point category, 5 categories. So I will put the labels here like 1, 2, 3, 4, 5. Labels are also done. So here you can see here I just draw the graph. So for drawing that, okay, let me see that what is the okay. Okay, so here I just draw the graph, right? So you can see here my 3 category contain highest value, my 2 category contain some minimum, then something like that, 1, 2 or something like that. We can also like do here sort index, so sorting these things, it's a name. So once that you can see here, now you can see here my output is there 1, 2, 3, 4, 5 and all the values. So also here you can see the using the mathematical way we can see here. So this is equal, right? We are just counting the values and putting it into the different categories. It's 5 categories. So once that is done, then we can say that okay, we can divide or split data set into 2 different train and test set. So we are using the same function train test split with the all the data set. Test contains 0.2, but we are using one parameter which is like this one. This is very important parameter. Stratify, which means divide my data or split my data based on that category. So I am splitting the data based on that income category. So here 5 categories, and so this is splitting the data into my 5 categories based on that income. Also the random state is 42 and shuffle is true. So something like that. Okay, we are doing everything is good, right? I hope this everything is clear until that point. And if not clear, you can like go or reverse the video and watch it again, so it will clear for you. So once that the straight train and straight test splitting is done, then we can say like we are just splitting that. Okay, straight train, we are just printing the first 5 row using the head method for the test and train. So you can see here all the split and split operation is done. So now you can say I am just like doing like test of income values. Okay, why I am doing that? Okay, let me explain you. So we need to check that. Okay, why our previous method is useless and why this method is very useful. So we need to prove that, right, in the mathematical way. So I am going to prove that. How we can prove that? So let me explain you what I did here. So straight test income values count means it's counting the values divided by length of straight test into 100 and round up. I am creating this only for the making it more reliable, or we can ignore that part as well, or we can just use this one. This is also we can use that. Okay, so I am just putting that. Okay, 0.35, 0.31, 0.17, 0. Okay, this is the fractional value, right? So I want to make sure that this is not readable, right? I want to just multiply this value into 100 and make it like feasibly or make it like comparably. So I am just doing that. I am just multiply this value into 100 and round to 2, means after decimal point I just only give me the 2 digits and sort the index means ascending or descending or something like that. So once I will do that, you can see that straight test my column which is already here, which is we do here. You can see here like straight test, which is first of all, and my actual data, actual income category, which contain all the income. So I am just like what I am doing, the values divided by means the total count of these values income category divided by total length of data set, total length of straight test data set. So I'm just putting here like all the values, I'm printing that. I'm here for the test as well, I'm putting all the values or printing all the values, and here for the actual data set I'm putting the all values for the same category, same column. Only the difference is that for the test and tail, for the test and the actual data. So here you can see here is the 4, right? Here you can see that our previous method, our old method, which contained 4.24, but our actual is like 3.98. So difference between 3.98 and 4.0 is only 0.02. But here you can see here our old method is useless because of, you can see here the difference is very large between this one and this one. But our newly created this one 4.0 and 3.90 difference is very small. You can see in every and each column you can see at 30.74, and here you can see at 31.88 in the actual data we got. In the actual population we have 31.88, but our old method which contained 30.74, which is far away, but our new method contains 31.88, means 31, it is exactly equal. Means our new split method or new method which mathematically proven that our training or testing data is the actual reflection of our population. So every other value also you can check here. We have here 12.09, but here you can see here 11.44, 11 point, and here you can see 11.43. 11.43 is close to 11.44, and 12.09, which is our old method, is far away from actual data, means 11.44. So this is the way we can mathematically prove that okay, our old method is not good for splitting the data, split the data based on the categories. So this is the method I am going to show you. Also this will be like I am explaining everything to you, right? How we can show that and how we can different that. After splitting this way, you can, like as I discussed earlier, we have like 10% possibility to get that value, right? So right now the 10% possibility goes to the almost 0%, not a 0% exactly, but almost 0%, because based on that subcategories we are dividing the data. So dividing the data on the categories which can reduce the risk of biasness. So that's pretty much from my side. Thank you.